Hello, today we're going to be looking at earned value measurements for project management. The examples that we'll be using in this video come directly from Rita Mulcahy's PMP Exam Prep 10th edition book. They could be found on pages, let me see, it looks like 235 and 236 in the book if you're looking for the specific questions. I'll go ahead and drop a link down to the book below too. If you're doing any PMP exam prep, this is actually a really good book to utilize. There are some few spelling mistakes, but the principles and the way they describe how the information will be presented to you on the PMP exam is actually really beneficial. So I'll go ahead and include that link down below. Our first problem that we're going to be looking at is building a four-sided fence. So simple square, and each side of the fence is going to take 1 day to build and has a budget of $1,000 per side. So that's how much we budgeted to build each side. And the sides are planned to be completed 1 day after another. Currently, the project has just finished day 3. Sorry about that, stuttered a little bit there, but we're at the end of day 3. So looking at this project status chart, which was given to us in the problem, we're right here at this point. So, okay, let's go ahead and look at what's going on. And by the way, if you need the reference, there's a legend I went ahead and built over here to represent all this information and understand this information. The bulk of the information, if not all of it, that we're going to be using is actually right in here in these little status of each side. So, present value. So the present value is going to be the estimated value of the work plan done to date. So to date, we're just finished day 3. We should have 3 sides finished, right? We said that each day was going to be one side, and we're going to do it in order. So if each side is worth $1,000 at the end of day 3, we should have $3,000 worth of work completed. That's what we planned. Our earned value is a little bit different from that in the idea that, okay, what did we actually do and complete out of all the stuff that we've completed to date? So side 1, we can see that it's complete. Side 2 is complete, and then side 3 is 50% done. Each one of those has a value of $1,000. So side 1, side 2, that brings us to $1,000 each, so $2,000 total, and then 50% done on side 3 would be $500. So our earned value here will be $2,500. Going on to our actual cost, we have our actual cost notated here. So we spent $1,000, $1,200, and $600 respectively. So that would be $2,800 of actual cost we incurred on the work that we've done to date. Our budget at completion is the budget for the whole project, right? How much do we allocate to spend on this project? Well, since each side costs $1,000, we have four sides. That would equal $4,000. Our cost variance is going to be the dollar amount in which our our earned value minus our actual cost is. So EV minus AC. And we'll actually write this in rather than reference the actual cells. It's a little easier if you're doing it for an assignment to reference the actual cells, but it's always good to write it out too. So we have negative $300. So that's actually not good, right? It means that we're over budget. So if we're negative on the cost variance, it means we're over budget. If we're positive, it means we're under budget. And if we're right at $0, it means we're directly on track. Directly on track is pretty hard to do, right? Just because some work might take longer than others than you anticipated, and that could be very, very, very small differences that can add up, right? So we're $300 be under budget or over budget rather, indicated by the negative here. And this is, let's see if we can actually do currency here, and we'll do currency for the whole thing. We'll have to update some of these, but that way we can actually see the negative dollar rather than the parentheses. All right, CPI, which is our cost performance index. So similar to CV, we're going to use earned value and actual cost, except we're going to be dividing earned value by our actual cost to get a ratio. So we'll go ahead and do that. So that's going to be equal to $2,500 divided by our actual cost of $2,800. And you see there's a dollar sign here. We're going to go ahead and just switch that over to general formatting. And then we'll switch or fix the decimal points. So we're going to 3 places out. So it's a 0.893. Similar with CPI as we saw in CV, our cost variance. Anything below a 1 for CPI is over budget. Anything above a 1 for CPI is under budget. And anything at a 1 for CPI is right on track, on target per our plans. Now we're going to go over to SV, which is schedule variance. Schedule variance takes a similar approach to the cost, except we're dividing or using our earned value minus our, can anyone guess? Plan value, right? So the way we can look at earned value and plan value is those are kind of like schedule related, right? If we plan to have $3,000 worth of value done in the schedule and we only have $2,500, right? There's a schedule issue there. So we'll go ahead and do the schedule variance formula, which is going to be earned value EV minus our present value. So that'll be $2,500 minus $3,000. Okay. What this is telling us is that we're negative $500 in value for our schedule, right? And similar to the cost variance, anything negative means, in this case with the schedule, it means that we're behind. Anything positive indicates that we're ahead, and anything at $0 indicates we're right on track. We're going to go ahead and do our schedule performance index, which is the SPY formula, and that will be our earned value, $2,500, divided by our planned value, which is $3,000. We'll go ahead and fix the formatting on this, and it's at a 0.833. Again, anything below 1 indicates that we're behind schedule. Anything above 1 indicates we're ahead of schedule, and anything at 1 indicates we're right on track. So far this project, taking a pause, we can see that we can look at the cost variance or CPI and the SV or SPI, either one. But having a negative here in cost variance and having a negative here in schedule variance, and a below 1 with the CPI and a below 1 with the SPI indicates that we're both behind on the schedule, right? And we're over on our cost for the project. We're going to go ahead and use the estimate at completion formula for the next one. One note with the estimation at completion formula is that there's several different formulas, right? So these all have different uses here. I went ahead and just kind of try to highlight them here. Let's change the color a little bit so we can stick these out. So pretty much you need to determine what kind of formula you need. So we have the first one, which calculates the actual cost to date plus revised estimate on all remaining work for the project. So we want to go to the problem again. Does the problem indicate that there's any change in the schedule or cost or anything related to this project because of the current project performance, whether it was positive or negative? And the problem does not do so. So let's look at the best fit. So the first one says that there's a revised estimate. That one's not going to be good. The second one says use this formula if the budget at completion for the project has no changes. So for instance, if we're not increasing the budget to counteract being behind schedule or anything like that, and that is the case for here. Let's go on to the third one. Adds the actual cost to date plus the remaining budget of the project. Use this when you have variances that are atypical and will most likely not happen in the future. Okay, and wow. This Excel does not want to scroll properly. It's because this cell is so wide. And then the fourth one calculates the actual cost to date plus the remaining budget that is modified by the performance of the project. And this one's saying use this when you think the current status of the project is going to be the norm for the remainder of the project. So if you have increase in costs, etc. We're going to go ahead and use the second formula here. It's the most simple one here, which is going to just take the budget at completion and divide it by our cost performance index. So our BAC, budget at completion, is $4,000. And then our CPI, cost performance index, is 0.893. What estimate at completion, EAC, is telling you is saying, hey, based on the current way this project is going, this is actually what we think we're going to need in budget to finish the project. One thing to notice is that we originally budgeted $4,000 for this project, and based on how much we've been spending and the work we've got done with that money, we're actually going to need $4,479.28. Estimate to completion, which is ETC, is similar to that, which is just going to be our EAC minus our actual cost. So this is again building off on our EAC here and our AC to get the remaining difference of what we would need to finish the budget or the project rather. So $4,479.28 minus our actual cost of 2,800. Yeah, 2,800. All right, estimate to complete is $1,679.28. So that's how much we're saying we'll need to complete the remainder of the project. And then variance at completion, so variance at completion is VAC, is our budget at completion. So we'll utilize this $4,000 minus our estimate at completion, which is the $4,479.28. So 4,000 minus 4,479.28. And what this is saying, the variance of completion, saying that we're actually going to be over budget by $479.28. Cool. We went ahead and completed this problem. So just one important thing to note is you want to know how to calculate everything in listed here, right? All these different formulas and all these pieces of information. You want to be able to get them and know how to get them because you can easily see how they start to build on each other, right? We know that CV, CPI, SV, SPI, EAC, ETC, and VAC are all built upon the first four sets of information that we have gathered, right? So very important that you know how to get these pieces of information to even start, and then how they'll build in and keep being inputs into formulas as we get into more complex equations, formulas, right? All right, let's go on to the second problem. So we're going to build a four-sided fence, similar to the first one. It's going to be a square. Each side of the fence takes 1 day to build and has a budget of $1,000 per side. The sides were originally planned to be completed one day after another, but circumstances changed, and the individual side can now be completed in parallel or at the same time. Currently, the project has finished day 3. So this is similar to the first problem, except we have one slight change, is that we don't have to do the work in order. What that has caused is that, for instance, side 3 and side 4 are both being worked on at the same time and both have different levels of completion. Okay, so let's go ahead and calculate the plan value. Well, plan value is still going to be the same, right? At day 3, we still thought we would have $3,000 worth of work done, right? We expect three sides that are $1,000 each to be completed. Our earned value is going to be our actual completion rates of each side times the value of each side, right? So $1,000 here, $1,000 there, $500 there, and $750. So our earned value is actually going to be $3,250. Our actual cost, we can go ahead and gather these from here. And let me just do some quick math. That looks like, wow, I'm really challenging myself today, folks. Yeah, 3,100. Perfect. So $3,100 in actual cost. If we sum all these up, $1,000, $900, and $600 and $600. Our budget at completion has not changed from the first one, but still it's going to be the budget of all the sides. So there's 4 sides, and each one costs $1,000. So that'll be $4,000. And when I say cost, I meant to say budget. So each one has a budget of $1,000. Our cost variance is going to be our earned value minus our actual cost. So it will be 3,250 minus 3,100. Our cost performance index is going to be our earned value, which is going to be the 3,250 divided by our 3,100. And for both of these, we can see that they're both good, right? So we're plus 150 on our cost variance, which indicates that we're actually under budget for the amount of work that we have performed. Our cost performance index is above a 1, which indicates that we're also under budget for all the work that we have performed, right? One important note So you might be at this point saying, okay, I understand what cost variance is, and I understand what the CPI is, and that they're two different formulas, and they both tell us similar things, if not the same thing, about the budget. If you're just looking at it at like a high level, most of the time you'll be using CPI in any sort of project status reporting versus an actual dollar amount, right? The CPI can really just easily tell are we under budget or over budget, right? Without needing to go into the dollar amount, right? So, for instance, if we had 150 here and we said the cost variance is 150, well, I don't necessarily know if that's like incredibly good or if that's okay. Like we're still gonna be happy with it, but I don't know the level of impact of being $150 under budget, right? And we can see that it's a 1.048. For instance, this on a different project being having a cost variance of $150 can be a 1.01, right? So the CPI is very good for really showing the impact of if we're ahead or behind on the overall project. All right, schedule variance. Schedule variance is going to be our earned value. Again, we're going to use earned value, and then we're going to take our present value of the work that we have completed up to this point, or should have completed, and it is going to be $3,000. So we have earned with the schedule that we have, we've actually done $250 more work than we should have at this point, which is good, right? That means that we're ahead of schedule. Let's go ahead and do our schedule performance index, which is going to be our earned value, 3250, divided by our planned value of 3000. And then a 1.083 is what we get for our SPY. We can notice that we're actually, relatively to all the data that we have, we're actually more ahead of schedule than we are under budget, right? 1.08 and then 1.048, right? Awesome. All right, our estimate completion. So remember, this is the tricky one in the terms that we have four different formulas that we can use. Similar to problem two, we do not see any changes or anything in the actual question regarding, okay, are we going to be doing anything to adjust now that we're performing this analysis, or like doing a rebaseline on our estimates, or not even a rebaseline, just re-estimating the remainder of the work, etc. And we're not. So we're going to go ahead and use the budget at completion divided by cost performance index formula for the estimate at completion. Okay, so that's going to be our BAC, which is 4,000, divided by our CPI, which is 1.048. All right, so our estimate at completion is $3,816.79. Now, this should tell you, if you're looking at this and trying to understand what this means, right? We said our budget at completion was $4,000. What this is saying is that the rate that we are going with the amount of work that we're going and the amount of cost that we're spending, right? It's going to actually cost us $3,816.79 if we keep completing the same amount of the work with the same amount of cost, right? So there is like a work to cost ratio, right, that we're kind of sticking by, and we're saying, hey, if we keep performing at a CPI of 1.048, we're actually only going to spend $3,816.79 on this whole project when it had a planned value or a budget at completion of 4,000, right? All right, ETC, estimate to complete. So ETC is going to be our estimate at completion minus our actual cost. So that's going to be our EAC minus our AC. So we'll go ahead and do that. So it's going to be $3,816.79 minus that $3,100. So we only need an additional $716.79 to finish out the remaining 50% of side 3 and the remaining 25% of side 4. All right, the last one, variance at completion. So our variance at completion is our budget at completion minus the estimate at completion, right? So that's going to be our BAC minus our EAC, and this is going to tell us, first what we planned versus what we're actually going to be at, what we're estimating to be at. How much difference is that going to be? So that'll be our $4,000 minus the $3,816.79. and we're going to say that we're actually going to be $183.21 um, lower. So if this is positive for our VAC, it's indicating we're actually going to be under budget when we complete the project, and we're planning on being under budget by $183.21. The VAC is one of the ones that you actually need to understand that if it is positive, it actually means that we're under budget. If it is negative, it means that we're over budget, right? Perfect. Alrighty. So just looking at the time here, how I can't find the time. We're 20 minutes in, so that'll be a good spot to end it. If you have any questions, please post them below. If you would like to see more content like this, anything like project management related, like network diagram and critical path creations, please let me know. There's a couple ideas I would like to do, and depending on the feedback, if people find it useful, I'll go ahead and start publishing those. And yeah, if there's anything you would like to see, to drop that below. Lastly, if you like the video, please give it a thumbs up. And if you want to see more of this, please consider subscribing. And yeah, we'll see you in the next one. Thanks all.